Okay.
G'day everyone, how you doing? Video here on quadratics. We're just starting a new topic here in Year 11 methods, and quadratics is a pretty heavy going topic. So I'm going to do this video on some of the basics of quadratics, and then I'll actually do individual videos on each style of a quadratic formula, and then probably some example ones as well. So check them out, they'll be coming soon. When we talk about quadratics, let's remember our linear for a moment. Linear is y equals mx plus c. You notice that the x value is only a power of 1. So when we go to quadratics, we're then looking to squaring that x value. Right? So here's our general formula, generic formula of quadratic, the most simple one you can get. Y equals x squared, or f of x equals x squared. Now I've added this in because a couple of students asked me the other day, what's the difference, sir, between f of x and y? What's going on here? Really, they're the same thing, it's just different notation. This is saying the value of the function at some x value is equal to x squared, or we can replace all that kind of fancy stuff and just call it y. So when you're doing your graph here, you can write this up as y for the vertical axis. If you prefer, you can say the function of x. That's meaning take an x value, get it into the function, and you'll get a y value out. So they're just they almost replace each other. F of x is probably better notation to use, but it doesn't really matter at our point right now. So we've got this standard graph here, y equals x squared. You would have remembered doing this years ago probably. Now let's be careful here, because if we put minus 3 in there, it's minus 3 all squared. So minus 3 times minus 3, the negatives cancel, we've got 9. So here would be 9. To write this out, because I've done the next one here, really what we would be doing would be going minus 2 squared. And minus 2 times minus 2, that would get me positive 4. Alright, so that would be 4. And if you follow the pattern along, this is going to be 1, 0, 1, 4, and 9. I did this one down here, I'll just complete it. This would be 3 squared. Because it's positive, I don't really need the brackets, but it's not a bad idea. It just signifies, hey look, that's 3 times 3, and then 9 would be your answer there. So I end up with this set of numbers. Now remember back to previous videos and other work we've done. We've got our domain and our range. So our domain is our x values. So it's our input values, and our range is our y values or our output values. So in this example, I've restricted my domain to minus 3 to 3. And therefore I get out a restricted range, because minus 3 to 3 on the x values will only get me certain y values. Now obviously there's numbers past minus 3 this way and past 3 this way, but in this question I'm reducing it just to that domain. So I'll scale up my graph now, and because I only need minus 3 to 3, I'll go here, here and here. Same on this side. And that will suffice for what I need to graph this up. Now you might notice that my x-axis, I've kind of put it further down than maybe midway, because I recognise that all of these are positive, and we'll talk about that in a minute. This scale here, I've got to get up to 9, so I might put 10 there, therefore 5 is going to be about there. Let's graph a few of these up. So minus 3, 9. Minus 3, 9 is going to be a dot about there. Minus 2, 4, there, a little under that one, maybe about there. Minus 1, 1, that's probably going to be about there. 0, 0. And then on this side, hopefully you can see it basically mirrors what's going on the other side. Something like that based on the accuracy of my graph. You'd be able to do a little bit better with lines on your page. So then if I connect these together, I should find something like, hopefully I'm not too bad on this one, ooh, not the greatest, I missed one a little bit, I'll just cheat and move him a little bit over. You end up with a graph looking something like that, kind of like a horseshoe-ish shape. Now I'll put here, notice the general shape of the graph, because this is what a quadratic looks like. It's a generally U kind of shaped graph. In this case, it looks like it's kind of the horseshoes the right way, so the luck doesn't fall out, or it's a smiley face, whichever you prefer. But the graph could go the other way as well. Okay, and we'll talk about them when we get over here later. We could also move the graph around, and we can also change the shape of it or the steepness of it. But they all fall to this general shape. I talked about the domain before, and I said I'd restricted the domain. Well, I'm just going to write the domain now as this, because I might have only looked at these values here, but I recognise that things are going on. You can see I've extended my line, and I realise that my domain is going to go on forever. So my domain is going to be the set of real values. But the range part of it, well, range is our y section. So I get nothing down here. When you look at the output values, all of them were positive. So I've got nothing in the negatives down here. So I'm going to say y such that y is the set of real numbers, but y is going to be greater than or equal to 0, because I'm only above the x-axis in this case. Not always is the case, but in this formula right here I am. So general shape we're good on, graphing we're okay on, table of values we're okay on. Don't forget this squaring. A negative value squared, when you're squaring the whole thing, becomes positive. That's a common mistake for students on this one. Now this is one form of quadratic equation. Let's look at the other ways that it might be presented. This one here, what you're doing is you've still got the square on the x here. Right? We would expand this out if we had numbers in here. We've still got the squared, so it's still quadratic. What we find is that this b value here, what it does to this is it moves it left and right. And we'll do some more work in that later. And what you find is if this is a plus something here, it actually moves it left. If that's negative something there, it actually moves it right. So it's actually your right and left movement. And for the moment, that's okay. Let's just leave it at that, right and left. This c value out the end, that's like any function that you do. If you just add a number on the end, what you're really doing is taking everything that you've got and moving it up or down by a certain amount. So if that was plus 5 on the end, you're taking this whole thing and moving it up 5. So the number on the end is our up and down. The a value at the front, that controls the shape of the graph, and indeed controls whether it's this way, a happy smiley one, or the other way down here. So if the a value is positive, we're up this way. We're looking positive, we've got a smiley face. If the a value is negative, we're down here. We're in a frowny face. If the a value is 0, we no longer have a quadratic, because it would be 0 loss of all of this, gone, disappeared. We just have a single number. So a is never equal to 0. A is either positive or negative. So I'm going to write here that a greater than 0 is going to give you a smiley face. A less than 0 is going to give you a frowny face. Now we can use better words as we get on, concave up, concave down, minimum, maximum, but let's just leave it there for the moment. There's a bit more work in here as well based around whether it's between 0 and 1 or greater than 1. We'll get to that later as well. Example on the right hand side here. So this is telling me that the shape of the graph is steeper than the standard one. So if the standard one was here, then that one is going to be steeper because I'm doubling the y value effectively that I get out of here each time. This value here is -3, so that actually tells me that the graph from the standard one is moving 3 across to the right. And I'm moving 2 units up. So as a quick sketch of this one, it would be steeper, to the right by 3, or there's 3, up by 2, there's 2. So that point there is equivalent to that point there. I've moved across 3 and up 2. And then the shape's got to be a little bit steeper, so it might be something like that. Only a sketch, but that's what that one would look like. With all of these, if you're ever unsure, you've got your ClassPad calculators, jump on graph and table, put it in, see what it looks like, so you go, oh yeah, I see that did move in the way that he said. That's good. Okay, this style of equation, often called the, this is often called the turning point form. and we'll dive into why, because we can get it out of here quite easily. This is often called the intercept form. The intercept form. So what do we get? Well, the A value is the same. The A value here is the same idea. If A is greater than 0, we're this way. If A is less than 0, we're this way. That's the same. That's okay, nothing different there. These two are then telling you where the graph will cross over the x-axis. Okay? Because if I was to make this thing equal 0, then all of this is multiplied together. This times this times this. So that means y is going to be equal to 0. Let's look at an example over here. If I take x equaling 2, then that thing equals 0, meaning the whole thing equals 0, meaning the y value equals 0, meaning I must be crossing over the x-axis. Bit of a way there, but follow with me. So this at x equals 2, the graph must cross over, so I'll put a 2 there. The second one's exactly the same, works exactly the same way. So therefore here, we're talking about -3 is the number that would make that equal to 0, therefore the whole thing 0. So maybe here is -3. So this kind of equation is telling me where it crosses over the x-axis. So both of these are telling me the x-intercepts. Now, if I know the x-intercepts and the number out front, the A value is positive, forget that it's 2 for a moment, just see it as positive. It means it's got to be this way. The only way I can go through these 2 points and keep it in a smiley face way is to actually draw something like this. And I'm going to go through my other example. Oops, I missed the 2 there. Oops, I'll just change that over. Artistic license, I can cheat. And my graph's not particularly symmetrical there, it should be, but you get the idea. So this particular graph crosses through these 2 points. The 2 means that it's steeper than my standard one, and because it's positive, it's got to be this way. Now the last form here is really actually just the expansion of this one into its full version. So if I let b equal 0, that part would disappear. If I let c equal 0, that part would disappear. And if I let a equal 1, the standard shape, then that formula would fall back to this one just here. So this is like the full version of this one. So, what does the a do? Well, it does a similar thing to all of these. It's the shape. So here, a greater than 0 is a smiley face. A less than 0 is a frowny face. Now, the B and the C in this one, they don't tell you information as neatly as what this does. In a while, in a following video, when I talk about this particular format, the B and the C we use in what's called the quadratic formula, and I'll show you where we derive that from. Because we can get a whole lot of things out of here, things like line of symmetry, we can get the x-intercepts, we can get a whole lot of stuff, but that's for that next video anyway. So I'll leave that for the moment. From here alone, without doing any extra work, would I be able to graph that, know exactly where it is? Probably not. Now if you didn't know quadratic formula, you couldn't factorize it or anything like that, then you'd kind of have to do it on the calculator. Trust me, we can factorize many of them. We can complete the square on many of them, and we can use the quadratic formula on all of them. So we do have other skills, but we're not quite there yet. Let's just stick with this part at the moment so we've got a general idea. Remember, it all comes back from here. It all comes from setting a table, graphing up what it looks like, kind of being aware of your range and domain. And then further on, we can look into these forms, and I'll do a video on each one of those in quite some depth so you can really get the hang of it with examples and the like. Hope this video helped. See you later.